Meanwhile, the Beekeeping project developed other innovative tools to further expand the data collection in the final years of the project. For example, accelerometers were placed in 3 mini apiaries to continuously measure the vibrations on the combs. These signals are being examined for the occurrence of pulsating vibrations. We have succeeded in detecting the so-called foraging worker piping. Piping are short sounds of about 1 second that the honeybee generates by vibrations of the flight muscle. Because the worker bee presses the thorax against the comb, the vibrations are also transferred through the wax and can be detected by our accelerometers. We are now investigating whether these signals can tell us something about the health of the bee colony. In addition to weight, temperature, sound and vibrations, we also want to measure gas composition inside the hive. Our literature review shows that moisture and carbon dioxide are the most interesting gases as it relates to the bee's circadian rhythmicity and metabolic activity. We found suitable sensors on the market and embedded them in wax foundations for measurements in bee colonies. In addition, we also want to spatially monitor the temperature on a comb with the help of a comb on which we have installed several temperature sensors spread over the 2 dimensions. It can be useful in monitoring the internal hive temperature during the winter if the cluster of bees has moved outside the range of a single fixed temperature sensor. Our aim is also to estimate the colony activities by measuring the number of bees going in and out of the hive. To do so, we are further developing existing bee counters to make them more efficient so that they can not only register incoming and outgoing bees, but also distinguish between the different castes and whether workers are loaded with pollen clumps or not. A database with annotated images has already been created for this purpose. The bee counter is going to make the distinction based on image analysis and machine learning. Honeybee health is also threatened by the use of pesticides. To help detecting these chemicals in the field, we are working on the development of a quick and easy to use field tool. We all know the rapid diagnostic tests of the pregnancy test, and more recently the rapid COVID-19 test. Within the Beekeeping project, we have developed an analog test for detecting neonicotinoids. Currently, the test works for 6 out of 8 neonics. In addition, we have also developed a rapid test for fipronil, chlorpyrifos, avermectin, and pyrethroids. It should make it possible to examine different matrices on the apiary for traces of pesticides. Additionally, in order to help understanding why bees die in case of abnormal losses, it is important to discriminate between pesticide and diseases. Thus, a similar rapid test for virus detection is also under development. Here we are still in the phase of immunization of rabbits and mice with selected synthetic peptides of the virus or with whole virus particles, and testing the sensitivity and specificity of the different antibody preparation. The latest innovative tool under development is a TaqMan genotyping assay. We know that resilience against the varroa mite is determined, among other things, by suppression of mite reproduction. This is a genetic trait of the bee colony that is determined by different point mutations in the genome. We have now developed a lab test to detect each of these mutations faster and cheaper in a population. It allows to check whether the protective mutations occur in a colony and what the impact is on the health of the colony. This will help beekeepers and bee breeders selecting the best honeybee stocks and reducing the amount of treatments that they need to help their bees survive varroa.